Morning, students. This video is meant to be a way to cover the key features of what we've been looking at. What are the actual key concepts that is the objective for you guys to understand, and also to discuss how you guys did the science. So how did you go about the investigation? So those are the two main points. The main thing here is embryos, and do they support descent with modification or not? So first, let's just go over what is descent with modification. And there's two key principles here. One, the genes are passed on from parent to offspring. So here's an example. Say this is a parent, has two kids. Obviously, some of these genes are similar because they look somewhat similar to the parent. And the second principle with descent with modification is the more closely related you are, the more alike you'll be. So obviously these two are much more similar than, say, this guy and this guy. This would be like your great-great-grandparent compared to you. You're going to look much more different than your great-great-grandparent. And you can also see that if one side of your family splits, you could look way different than the other side of your family. So this is the basics of descent with modification. Again, there's these two key components. I would encourage you guys to get those in your notes. So pause the video and play the video. Alrighty, so next, the main question of our investigation: does embryonic development support the theory of descent with modification? Originally, I wanted you guys to all participate, so I would say, think about, did you say yes, or did you guys come up with the answer no? Just as a overview, the main question here is, do the embryos support the idea that things can change over time and that we'd all have a common ancestor? That is the main question at hand. Now, to help answer that question, we do have evidence for the theory of descent with modification using embryos, and I'm just going to cover the main pieces of that. So one of the things that we mentioned early on was the idea of homologous structures. So homologous structures are any feature that looks similar and is built in a similar way. So embryos have a number of these. So the pharyngeal slits. Do you see all these little bumps on every single one of these? Those are pharyngeal slits. Those are the precursors to gills. So the idea here is that life started in the sea. We all had gills at one point. So you would technically be related to a fish way, way, way in the past. A second homologous structure is the post-anal tail. So you can see that all of these embryos have these post-anal tails. And again, that can go back from, think about the fish, they have the rear fin. Same thing. So all the common ancestor. Then lastly, do we develop limbs? You can see here that most do. At least all of these examples. So we have the fish, I believe this is a salamander, turtle, chicken, looks like a mouse. Oh, didn't want that. Let's go back. Then we have the human way at the end. So this is the evidence that embryos do support the idea of the theory of descent with modification. At least parts of it. You guys even came up with other ways to show it, such as counting the number of cells. We all have, like, all embryos start the same when they split off, starting from 1 cell to 2 cells to 4 cells to 8 cells. So you guys even came up with other ways to show evidence for this. Alrighty. But, like any good scientific theory, is there any way to disprove it. So one of the most common questions about this is, if we all have a common ancestor, then why are there still anything that looks similar to us? So for humans, this would be like monkeys, apes, orangutans. Why are they still monkeys or apes or orangutans and not humans by now? So take a moment. Can you think of any reason why they would still exist? So I'd encourage you to ponder this for a moment. It's more fun if you play. All right, but I'm going to go on and give one explanation. Now, instead of using the apes and monkeys, I'm going to go to the tortoises, because we've talked about these, or we've seen an example of these in a prior video. And the idea here is that you'd have to connect the principles of natural selection and the ideas of the theory of descent with modification. So imagine you place the same tortoise in two different environments. Both environments are going to put a different pressure on. So one of the tortoises, the saddleback, ended up getting a very long neck. That was an advantageous trait because its food was higher up in the trees, whereas the other tortoise would stay low to the ground. All of its vegetation, all of its food would stay lower, so it never developed that ridge, saddle of the shell like this one did. So the idea here is that if you place the same organisms, like say you put two populations with the exact same traits into two different environments, those environments over time are going to push them, which is what natural selection is, into looking different. And then if you keep them separated for long enough, then that would lead to different species. So now if you think about the example with the humans, so way back we found evidence that humans have originated in Africa, and parts of Africa was a forest, and then parts of Africa were the plains. So once the two populations of our ancestors got separated, one went to the plains, which is where humans supposedly arose, and the other stayed in the forest. That would explain why we developed different traits. If you're in the plains, it would actually be an advantage to be able to stand up and see over the tall grasses, whereas when you're in the trees, you're going to want those strong limbs, and you're going to more look like an ape than you would a human. So that would be an example of why this doesn't just change. Like, why do we still have all those other organisms with descent with modification? Shouldn't they have all changed by now? Alrighty. That was the content, and now we're getting into how did you actually do the science? So there's a couple questions here that I want you guys to pay attention to, or at least to put your attention on, because you all did this, and you probably just didn't even think about it. So what evidence do we have that there are multiple ways for scientists to investigate a question? Think about the different groups. All the groups had slightly different evidence. So, and I'm talking about the embryo research. So all of the groups had slightly different evidence. So we all took slightly different paths, but the great majority of you guys all said that the embryos did support the theory of descent with modification. So even if one group looked at one piece of evidence, or a couple pieces of evidence, another group looked at slightly different ones, we all ended up heading down in the same direction. So that's evidence that there are multiple ways for scientists to investigate a single question. Secondly, how is the idea of structure and function important in this investigation? So structure and function. I think the best way to understand this, if you do not, is think about a hammer versus a screwdriver. Their structure determines what they can do. A hammer is much better at pounding nails into the floor or wood or anything else than a screwdriver would be. Similarly, a screwdriver is much better at screwing screws than a hammer would be. And that's based on their structure. So one thing to keep in mind here is think about the embryo's shape. Think about all those different structures that we looked at. So the pharyngeal slits, the postanal tails. Think about those when you're thinking about how important, excuse me, how important those different parts are in this investigation. Because you have to tie that to what we used to have to live in. So if according to the theory of descent with modification, and if we all had a common ancestor, that means we would all come from the sea way, way, way back. I'm talking way back, like not just millions of years, but billions of years. How does that structure and function of the embryos, how does that come up in this investigation? So again, I want you guys to be thinking about this and not just use my answer. Alrighty. That is the brief summary of the embryo investigation and the ways you guys did science. You will use this to help you answer the questions which you will be doing next. Peace.